Antonio es doctor e ingeniero, ha pasado casi toda su carrera profesional por el mundo, en Alemania, y bueno, como he dicho antes, pasó por muchas vidas, más de 15-18 años en ASML, la empresa que precisamente ha estado comentando Ignacio, ¿no? Que es una de las empresas de la que depende la industria de semiconductores en el mundo, sobre todo en los más avanzados. Él fue además director de producto y responsable de desarrollo de negocio de la compañía, lo cual es decir, bastante. Y por tanto, pues Tony tiene a lo largo de esta trayectoria profesional de más de 30 años una visión global de lo que es la industria, de lo que ocurre, de cómo se genera el negocio, y precisamente de eso es lo que estamos pensando un poco, que es ese efecto tractor que necesitamos del mercado para que todo esto al final salga a cuenta. Y ha venido desde Alemania, se vuelve hoy un viaje relámpago, lo cual agradezco un montón con él que esté aquí. Él además tiene una empresa de consultoría que se llama Technologies, que actúa como asesora tanto de la Comisión Europea como de la SED, como la empresa nacional que gestiona los fondos del FERTECHI, y además está también ayudando a desarrollar estrategias en Europa, y con eso desde aquí.
Muchas gracias, Daniel. Y bueno, muchas gracias, un honor para mí estar aquí también. Y bueno, mi presentación la voy a dar en inglés porque he estado todavía en esta industria y la lengua que se habla en esta industria es el inglés. Entonces, si me perdonáis. Pero bueno, solamente lo que decía Daniel, he escrito un poco mi historia, no voy a repetirlo todo. Yo soy mallorquín, criado en Mallorca, pero mi formación universitaria y profesional la he hecho en Alemania y en Holanda. He trabajado en empresas del sector como Infineon, como Extron, como ASML, más de 25 años, y lo bueno es eso, en muchas diferentes funciones. He estado desde ingeniero hasta miembro de business line, estrategia, marketing, he hecho muchas cosas, he estado en compras, incluso manejado una fábrica, y entonces tengo bastante experiencia, y esa experiencia es lo que me da la oportunidad y el honor de ayudar a España a montar la industria de semiconductores, que es lo que estoy intentando hacer en esta fase final de mi carrera. Aparte de eso, pues sí, soy business angel, estoy metido bastante en el tema de startups, he invertido en varios startups en el tema de computación cuántica, sensoría cuántica, en fotónica, en nueva litografía, y entonces estoy bastante metido en esto más de forma privada. Bueno, desde aquí ya cambio el inglés, ¿vale? Y eso, y he estado en muchas fábricas, Estas son fotos mías de 50 fábricas que he visitado, que eran mis clientes cuando estaban en ASML. Y sí, las conozco muchas de ellas, no todas, pero muchas. O sea, ASML es como monopolista en el tema de litografía, entonces seríamos a todas las empresas de chip, que sean IDMs como Nokias. Eso es lo bueno. So let's talk now in English. So my presentation, in fact, will follow a lot what my three presenters showed before. And so I'm not going to repeat a lot of things. So if there is a slide showing something that, for instance, Ignacio showed before, I will pass and just focus on the new stuff. And what I'd like to do today is basically zoom in from the big picture of the semiconductor industry, which are the mega trends, what are the challenges, move to Europe and what Europe is doing. And it's not everything is good enough. You will understand why. And later I will then move to Spain. And what are the opportunities in Spain? What are the things that are done in Spain so far? And what needs to happen in the coming years? If we want to build what I always call a long-lasting semiconductor ecosystem. So that's the story, and this is something that was mentioned already today. The market growing well over 1 trillion. You see that on the right bottom side. And the areas which is growing fastest is indeed servers, data centers, and storage, which are driven by artificial intelligence, which is the main driver today. Unfortunately, the classical markets like personal computers, smartphones are very, very weak. And those are the volume markets. And this is having an impact on many factories. Not every factory is doing very well these days. So we're hoping for the killer application driven by AI. It's called AI in the edge of the network, which is going to drive again our research of personal devices in the coming years, but this is not visible still. The drivers are very relevant. In fact, it's not just the left side, it's not just the technology driver, where you are talking about connecting everything with everything through the network, cloud infrastructure, some of that exists already for a few years, hyper-connectivity, Internet of Things, as we mentioned already a few times today. But what is the next one is bringing the artificial intelligence to the edge, making cars intelligent, self-driving, making your devices extremely intelligent. So in a sense that they are really starting to think for you. That's what I mentioned before. This is something that is going to be a long-term driver for many users at home. Then things that are on top, which are really challenging things, are challenging also creating a lot of technology, are especially climate change and resource scarcity. That's a very relevant topic, which are driving energy transition, electrification of cars and infrastructure, making agriculture more efficient. And these are very interesting opportunities for Spain and for Europe in general, because it's a new game, and it's not just about using the latest technology for that, but having the right applications and developing the technology and software and hardware behind. And since, for instance, energy is a very relevant topic in Spain, we could do lots of interesting things in this area. And I will talk about that later. And last but not least, the social economic shifts. Of course, population is becoming older. Medical technologies are needed. I will give some examples of startups in Spain which are doing good things in this area. Automation, so robotics, something that will come more and more into the real world in the coming years. And last but not least, technological sovereignty. So this is a slide that I took from ASML. We will talk about, in fact, I have not used the notion of sovereignty in my title or in the outline for good reasons. I'm not asking Spain or Europe to become totally sovereign or self-sufficient. That's something indeed that China has been using, because it is illusory. But we can still develop an industry in Europe which is competitive and good enough with less dependency on other continents. And let's talk about that in a minute. Yeah, this is one last slide to just explain what artificial intelligence is doing. In fact, it's basically making what we have put together, the cloud, the networks, connecting billions of devices, making them more intelligent. And AI will not be needed everywhere, but it will be needed in a different way as today. Today we are investing billions, or not big, but mainly the Americans and the Chinese, into so-called large language model training centers. So data centers with lots of GPUs from NVIDIA and lots of memory, trying to learn what is, for instance, in the web, and making out of it something which is making sense. But this is just the start of the AI world. The next steps is really starting to use this intelligence not just for a query by Google or by Microsoft Edge. What you really want is having this AI embedded in your software, in your mobile device, and create value other than just answering questions. And this is still not a clear thing. So this magic business model, how to use AI, is being still sorted out. Today the money is because we want to build the best AI models, and we want to have the fastest infrastructure, but still, what do we do with this? We will see. So in fact, there is a lot of discussion in the especially in US high-tech scene about whether there is such a huge investment needed to do what Chinese companies have done with 10 times less money. So that's a discussion. But anyway, this you see AI is positioned as the next big thing, beyond PC, internet, and smartphones, and that will last for many, many years. This is the ecosystem that is behind this high so-called ICT technology, information, computing, and technology, which is the most relevant industry on our planet, and also the most innovative industry on our planet. And you see the different colors across the value chain, starting with equipment makers. You see top left my photo company with their peers, but then the semiconductor manufacturing companies, TSMC. By the way, the black ones, the dark gray ones, are those companies incurring losses. You see that indeed Intel, Samsung. So not everybody is making money these days in the market. And next slide, you see the next level, the design companies. NVIDIA is a good example. Then the companies which are basically vertically integrated, like Apple. They do design. They are not doing the manufacturing itself. This is still done at TSMC, but they do all the way to the ecosystem. They build the operating system, all the way to the devices. And this is, it's for good reason, the most valuable company in the world, next to NVIDIA for other reasons. So this ecosystem created 865 million, thousand millions or trillions of earnings before interest and taxes. So basically earnings or margin in 2023 and similar number in 2024. And the good thing is that they have reinvested half of the money of the EBIT, so what they earn, into the development of the next technology. So this is a huge amount of money, and there's good reasons, because those companies, most of them, are making real money, and they are driving innovation, and they are making our lives easier. One thing that I want to highlight here is there's almost no European company here. In fact, you see our company SML, and you need to really start to search. You see Siemens maybe there, and Telecom, yeah, but it's not a lot. This is mainly an American show, with China starting to play a role. Yeah, so this is just give you a picture. Now there are some challenges. So not all the good things are good, and challenges are also opportunities. And I would like to highlight the first three, but let's talk about those. First of all, Moore's law, so has been presented a few times already today, is slowing down, is changing. And the solution of Moore's law has been for many, many years shrinking, so making the transistors smaller. You start to change the structures, as mentioned by Matthew. And you are starting also to look at other ways to move the technology roadmap forward. This is also opening opportunities, and advanced packaging or heterogeneous integration is one of them, but also new materials. And these new opportunities are openings for new players. That's one area we will talk later when we talk about play. Second one, fragmentation. That's also a challenge and an opportunity. In the PC era or mobile phone era, you had 2-3 big applications like PCs, and these were driving 78% of all the chips. Now you have chips everywhere. The proliferation of applications is increasing significantly, especially Internet of Things has enabled this. And this is creating also opportunities, because then you have lots of niche markets, which are some of them not well served, which need new solutions, new technologies, and that can also help. It's not very efficient on the one side, because, as mentioned today, chip prices are significantly cost sensitive or volume sensitive, so the more volumes, the lower the cost. But you can still have markets which are added value markets at reasonable prices, if the competition is limited to this market. So finding the right market, niche market is relevant. Yeah, that's the topic of today in the middle. All of a sudden, the world is not anymore as it was 10 years ago. It has to do with the geopolitics, with the increasing tensions between the US and China. We'll talk about that later. And Europe in the middle somewhere, and the fact that since COVID, we know that supply chain can be used as a weapon, dominance in the supply chain. And now with the whole discussion about tariffs initiated by the US, this is getting even worse. And I will give you the example of China and rare earth materials in a minute. And this is a very difficult thing, because I said today a few times, the most efficient industry in the world has been, and still is, semiconductors. It was a highly specialized, highly consolidated, concentrated industry. Now the graph of that. And all of a sudden, you're trying to review the same thing in your region. And this is making the whole thing less efficient. But it's what the politicians, and I understand the arguments, want to do, and there is little force to change that, at least not for the foreseeable futures. It's not going to be just a trend of years. And of course, just do not forget ESG, environmental, social sustainability, is making, we are not going to talk about that today, making semiconductors, which is not a very clean technology, lots of dirt stuff coming out of the fabs. If you want to make semiconductor factories more green, that's not an easy one, because the materials that you use are highly selective. You cannot change any material, in fact. It's extremely difficult. And next to that, they use a lot of water, they build a lot of dirty water, a lot of gases. So it's a challenge for the industry. The industry is kind of trying to find solutions, but not going to be easy. And last but not least, energy. Energy hungry. Just one data point. If we keep on the roadmap as it is today, and we take a look at artificial intelligence, and we look at all the plans that are made by the American entity, Amazon, Google, Apple, in terms of data centers, the energy consumption of just these data centers behind the intelligent networks is going to be about 20% of the total energy bill of the US by 2030. 20%, just this infrastructure. And if it keeps going on like that, and the growth rate keeps like that, by 2040, will be 60%. Or it could even exceed the whole plan. So this is why companies like Meta, now former Facebook, are building their own nuclear power plants just to run these data centers. But let's just focus on the three top topics. I'm not going to repeat. Moore's law is basically a law of economics. It's a self-fulfilling prophecy. If you do better chips, more powerful chips, you can put more powerful applications, which bring added value and reduce the cost, and this will drive next generation of chips. And this has been going on very well. The problem is this whole vicious circle is slowing down. And why is that? Because this is again Moore's law, and again just to, it's a miracle. It's amazing to see. If you think about this, this is the number of calculations per second per constant dollar. Of course, the dollar has depreciation. It is 18 orders of magnitude. It didn't start just with Moore's law in '65, but also if you extrapolate that to the past, you will see that there has been always innovation in the industry, and it keeps going on. And yeah, the examples he gave were very impressive. You know, about the Eurofighter costing 10 cents. That tells you everything. Yeah, but this is also something that Ignacio shows. So you see
you were also, estabas pisando también mi parte, ¿no? But that's a bit of the same, yeah? This consolidation doesn't mean, yeah, don't forget, there is still a lot of demand for these factories here. So it's a very important input there. I don't know for almost any factory, with some exceptions of DRAM factories, which has been closed in the past. So most of the factories built after 2000, in the 90s there are still some which were closed, are still active because there is always a market for these chips. There are also ways to upgrade the factory, bring it to the next node. And therefore, once you put a factory in place, provided you have the right market and the right pool, as mentioned by Daniel, then you will also have business for many, many years to come. The products that ASML produces, I was responsible for a large part of that, also last 25, 30 years. So it's not something that exists. But yeah, coming back to the leading edge part, you have here Intel basically, which is in big trouble. They lost the, how you say, technology race against TSMC. Also Samsung is not doing very well these days. And this is very bad in a sense. You have only one company in the world doing the most advanced chips and one company doing the most advanced lithography. Then this part of the market will have a hard time to exceed, to develop forward. Anything else to say about this? Yeah, of course. Does it make sense to put a factory for 3 nanometers in Spain? Of course not. Of course not. We should start doing things which are doable and learn and help the people to do these things before we go to the moon or to Mars. Yeah, and those are examples of how to drive Moore's law. Next to the lithography swing and putting 3D transistors like FinFETs, Gate-All-Around, or CFETs. You can also look at the way you are stacking memory, so the whole way of making system on a chip or system level integration. And this is an area where there is not enough supply, not enough companies, and a lot of innovation needed, not just for the GPUs or for the iPhone chips, but also for many more things. So this is one area where I would advocate to Spain to start looking into that. And of course, the whole optimization of the system is also very, very relevant. One key message for you: not all chips are scaling, not all chips are making things smaller. There is also a so-called non-scaled chip technologies which are not making it, scaling doesn't make sense. For instance, for a sensor, in case of a sensor, you need a certain size, a certain area to have a certain sensitivity or efficiency. The same with radio frequency chips. You need to make them fast and efficient. And also power chips. To switch a Tesla engine or a big windmill, you don't need to have very small chips. You need to have the right technology with the right material and the right design. And this opportunity is about 1/3 of the market. It's not peanuts, $350 billion. And there is highly fragmented. Now, I'm not going into details here, but there are lots of interesting things going on in this area. Of course, this is the classical market, the 2 nanometer, 3 nanometer, the DRAM, 3D NAND chips, and this market is gone. And gone in the sense that it's concentrated. We spoke about logic a minute ago. Also memory. If you look at dynamic random access memory, DRAMs, which are the chips that are used for these fast GPUs, you have basically 3 companies: Samsung, SK Hynix, and Micron. 2 Koreans and 1 US company. And there is no way to go into this market as a new entrant. So that's a bit of the very fast summary of the worldwide picture. Let's talk about Europe. So this is how it started. You remember 2021, we were in the middle of the pandemic here, everywhere. And all of a sudden, the ports and the airports closed. And there were people just still at home nothing happened. And then all the car makers, also in Spain, there's lots of car factories, did not get any chip. And all of a sudden people wake up and say, oh my goodness, we need chips. They are important, no? And they come all from Taiwan and from Singapore and maybe from China. We are still dependent on them. And also the Americans, they realized that the globalization, especially the globalization within the semiconductor industry, was bringing dependencies. And they are extremely high. And then, of course, Mr. Biden said, wow, we are going to do the US Chips Act. And by the way, also the Europeans said, and we also do. It was a bit of a political thing. And after that, it was really a supply chain disruption issue. But after that, the next issue came, which was the geopolitical conflicts, which are now even being accentuated by the current US administration, created even more problems. And then this trend of, oh, we need to be self-sufficient, or we call about technological sovereignty, that's the word that is needed or used. It tells you what is the thinking of the people. And we are talking about Europe, not talking about every country, but Europe is a relatively large market. We need to do something. This is what I basically was talking about. If you like to read the book of the right, Chris Miller is a very good one to understand what happened since the creation of the transistors all the way to today. I suggest you to read this. There are other very nice books to understand the whole thing. Also, my former company ASML plays a big role in this whole thing. And yes, this is about having the power, because this is from 2017, I think, yes, from the Economist. The oil, so the data is the new oil. We could make a new picture which is called AI is the new oil. So those companies are investing hundreds of billions of US dollars to get the supremacy, or to keep their supremacy because of it. Yeah, as a result, everybody say, oh, the government, we are going to put money in getting factories in our own region. It is not new. In fact, Singapore created their own ecosystem already 20 years ago by doing that. Same with Korea, a bit of Taiwan, where the government subsidies were always a good one, up to 40% of the capex investments paid by the government, the land for free. These kind of things happen a lot in Asia in the past. What is new is more here in Europe and also in the US, where they say, oh, we are going to put whatever, 43 billion euros, $8 billion. And this, the idea was that this would act as a turbo, like in a car, né? So as an accelerator. This was the idea. Né? And if you look back in 22, this is from 23 from SEMI, all of a sudden, almost 100 new fabs, was twice as much fabs as normal in a period of 5 years, were announced by the end of 22, beginning of 23. And yes, 30 new fabs in Europe. Wow. I've never seen this. In fact, I'm in the industry since really the 90s. Never seen this. But this was a wish. This was not the reality. In fact, in the case of Europe, I show you that was not. What is happening, however, on the other side of the ocean again, how many? 63. Asia. Those are happening. Yeah, let's look at it a little bit more. So this was this idea of Europe, indeed, moving from 8% of the total worldwide capacity by 22 to 20% by 2030. And here comes back to Jorge. Indeed, if you want to double or more than double your market share in a market where the others are investing, you have to invest 4 times or more. So you can do the calculation. This is the famous example that was given today. This was, when I saw this, and I saw that the number 43 billion, I said, what? That doesn't work. This is knowing what the others are investing, and then you do the math, and within 2 minutes with a piece of paper, you say, that's never going to work with 43 billion. They have to do 160 billion. Then you start to talk about maybe reaching 15 or more %. 200, yeah. And this was, in fact, a picture back in 23. This is from a French consultancy. And these were really announced factories. And you see here the big factory from Intel in Magdeburg, in Germany, and many other things. And then you see what really happened afterwards is that many of these fabs, and this is something I mentioned in his pioneer, from going from 106 billion total investment, these are just the big fabs, we ended below 60 because, of course, Intel closed the one, or never made the one in Magdeburg, and also in Poland, it was a back-end factory plant. But also Wolfspeed, another company from the US, planning a 1 billion factory in Germany, went bankrupt, or is in Chapter 11 currently, so basically applying for bankruptcy. And also a big factory from STMicroelectronics and GlobalFoundries in France, in Paris, has been pushed out. So all of a sudden, 40, 50 billion of euros disappear. So nothing with the 20%, forget. If we keep the 8%, it's going to be really good. And don't forget, Europe has around 15, 16% of the global GDP. So we are half of the GDP, so normally we should be around 15% market share in semiconductors. That tells you the story is, yes, this is not going very well. Something went wrong here. And also the dependency on US investments. There was also discussions with other US companies like Texas Instruments, Micron, etc. But then they were attracted by the US CHIPS Act, investing in make America great. That's the same story now. In fact, and they decided, okay, we stay in the US. Just Texas Instruments, two weeks ago, announced the next 60 billion project in the US. And Texas Instruments is doing analog devices, or analog chips. There's nothing with 2 nanometers. But you can also put 60 billion into this market. Imagine how big it is. Yeah, this is the forecast for the factories in the coming years. Here you see the remainder 7 factories. They include IMEC in Malaga. I have to say this is not a factory, it's a research center. But just for completeness, it looks very nice to be on those third-party slides. But look at here, China, 25, 21, Taiwan, 4 more. The US, 11, pretty big factories. So, in summary, this with the 2030 and the 20%, it's not going to happen. And we need, if we take it really serious, we need to really go and say, we're going to put the 200 billion on the table, and we are going to have an aligned, well-defined strategy for Europe across the different industries. And that's missing. So, my summary for the European part. We have too high dependency on external countries. We see that for the leading edge part, for specialty wafers in the so-called high bandgap semiconductors, which is a very interesting area, by the way. All kind of microcontrollers, analogs, they are short here. You can argue, yeah, these are really the washing machine, but also lots of car stuff. We could argue we don't need that. Maybe if there is some intelligence inside or some differentiation, we should think about doing that. And the OEM should define those chips and design them. And of course, advanced packaging of all kinds of chips. So here, double down, I've said 100 billion, let's put 200, because otherwise we will not make it. And then, in order to get there, the most important thing you need is people, is talent. You have to, there's some good analysis made by SEMI Europe, saying that if we put these factories in place, we will need 100,000 educated people to work in these factories. And we're not talking just about PhDs and engineers. We are talking a lot about operators with they don't need to go 5 years to the university. They can do it in 2 years and they can run machines. And that's very important. And this is something that's starting to take place in Spain, but we need much more. Probably, if we want to be a player, we will need, of the 100,000 people, at least 15 to 20,000. So that's a task. Yeah? It's really real stuff. Lab to fab transfer. We'll talk later about Spain. And that's something which is missing. We have very good research laboratories across Spain. But all the processes done there are with lab equipment. So you invent something and you want to make it at TSMC or in a foundry in Europe, you have to redesign the whole process again. So this lab to fab transfer is extremely relevant. So you have to have a process running on equipment that is used in factories and foundries. I will talk about that later. And then what you just said, we need a good plan, well orchestrated, and here we have to have a good alignment, not only within Spain, but also within Europe. Let's talk about Spain. Yeah, that's also from 22. Yeah, this was the announcement. My watch is this. This is something that was announced, in fact, at the chip in May 22. I was still working for SML at the time, but I had my plans to do my own thing, and when I saw that this is the destiny, so I should take part of this story. We have basically our economy, you know, that is very much service-oriented, tourism, construction, and we need a stronger industry. And since semiconductors is the backbone of the majority of industries, we have to have a real presence in this area. There was a very nice analysis done by, I think, Ametic, which is together with ISEMI, an organization, and this is good because you see how these organizations have grown in the last years. There are lots of members, and I encourage you to take a look at those. And there was this analysis was done, and then what you saw is that for fabrication, there's almost nothing. Yeah? And in order to explain you a little bit better, I would like to show you the supply chain of semiconductors, which I think are very key to understand what the problems are. So you start with R&Ds and startups, I would call it innovation centers, and then you start to make chip manufacturing, and you will have, the first thing you need to do is designing chips, for which you need some design software and also IP blocks, intellectual property blocks. And then you have the manufacturing of the front end of the device, basically the top part of the wafer you saw. It's called front end manufacturing, for which you need factories and equipment of all kinds. And then, of course, the whole assembly, test, and packaging, and you need also materials for both. In fact, and this part is what we call manufacturing. And last but not least, the final use of the consumers, but also the B2B business, the car makers, the device makers. And this is how it looks. Of course, you have different business models if you are an integrated device maker or you are doing just part of it. If you look into the worldwide split of the tasks between the different parts, and this is a more detailed out, you will see that it is highly concentrated. For instance, let's take electronic design automation. The software to design the chips, this is a US business, 65%. Cadence, Synopsys, yeah. Those are the companies doing that. If you take, for instance, the assembly testing devices, this is a Taiwan topic, or Singapore. Here in Europe, you have nothing, zero. Intellectual property, also US. So, you see light blue is Europe. Not good. And the point is, nobody has everything. So you can make the analysis of this graph, you will see, it's not good. And just take the example of rare earth materials, because that's one that everybody will understand. The majority are in China. And yes, you may find some of them also in Spain, but start to make the mine and get the permits. Good example, we were talking about yesterday, lithium in Cáceres. Not easy to get this up and running. So there is always a dependency from other countries, and this is what sovereignty means, not self-sufficiency, but more sovereignty, not total sovereignty. And in fact, if you think about China, we see China sometimes as an enemy. I don't think that. They have done their homework in semiconductors. They have built their own very well balanced, you know, ecosystem, and half of these companies are less than 10 years old. I have visited at least 20 factories in China, and 10 of them were factories of new companies set up since 2015. And when they do that, they do it seriously, and they go, boom. Why not here? I'm not saying we need to copy this, because we will have our limitations, but it is possible. Yeah, coming back to Spain, we have SET, is the current organization in charge of managing the perfect chip money, the investments of the 12 billion that were assigned. And these are recent announcements, so they decided to do that. They have started to do something on the education. Don't forget the 20,000 people we need. They have put some experts together. They have also incentivized co-investments with private equity investors. I'm chairman of one startup which is currently discussing such a model. Of course, IMEC, we will come in a minute, and also Spark, which are two examples I'd like to show you in a minute. But if I look into the picture of Spain, so the same picture and how we basically see Spain in the different parts of the value chain, we were already relatively strong in R&D, and now we have put two very nice projects in InnoFab and IMEC in this area, so we are putting the money to enforce even more innovation. Nothing against that, but this is not enough, no? Because this is always, R&D is always 5 years, 10 years out. We want an industry, not just research centers. Yes, in design we're making some good progress, some companies investing. I will give an example. The first foundry announced a few weeks ago, Spark, and I'm involved in this project. It's a good example I'd like to align, but there are also others like Broadcom or IBM here, which are either not happening or in debate. And the point I want to make here is, yeah, we have done some things, but still not enough and too slow. And more has to happen, and fast has to happen in the coming years. And don't forget final use. Spain has relatively great industry when it comes to device and car makers and machine makers. And Telefonica is an example of a technology company which is real size. Indra is another one. Why not to put those guys more into the picture? Because if they start to, for instance, to design their own chips, they will change their position in the value chain. They will start to make sure that the rest also come from here. And that's something we have to discuss more. And I will now just give a few analysis of the three parts and then finish my talk. So this is what I was showing you before. The Spanish academic world, which has been developed over the last 60 years, and we saw today some good examples with, you know, very good universities, good education, and even good labs in some cases. We have the Centro Nacional de Electrónica, CSIC, with the free Salas Blancas. No? There is some things which are good here. But what is still missing, is the next step. So moving to fabs. And here, InnoFab will play a role. IMEC, let's see, IMEC is basically building a subsidiary of what they are doing in Belgium. The focus of IMEC has been on big chip companies, and probably Malaga they also will do the same. Let's see how the impact of IMEC on the local ecosystem will be. And this is the picture of IMEC. You see, this is the investment that is going to be done, around 600 billion, pretty decent 300 millimeter clean room. There is not 100% clear what they are going to do there, but they're going to be compatible technologies to what they are doing in Leuven, which means for me it's going to be about heterogeneous integration, wafer bonding, which are compatible with the string roadmap that they have in EBET. So, cool thing, let's go for it. a big bet, it's not an easy building to make, frankly speaking. But we have another one, and this is the one I am deeply involved in, in the planning of this building, which is InnoFab. InnoFab is going to be located in the Alba Cyclotron Technology Center near Barcelona, in Cerdanyola. And it's going to have also a 2,000 square meter clean room for the so-called VOC technologies, which is a bit what I think Jorge was mentioning today. So technologies which are going to be mature for markets in 5 to 15 years. Quantum technologies, advanced photonics, emerging non-volatile memories, and yes, neural computing, biomedical sensors, and image sensors. Those are the technologies that really are very interesting, where there is a needs for innovation and where there is no fixed ecosystem. And this is what we're trying to do with the clean room. We're going to put in the clean room basically this lab to fab concept. We have to have spaces for companies which can rent their own clean room spaces, and we're going to work on R&D programs with them. We have in the middle we are going to have a big industrial lab. And what is really new in Spain is going to be a pilot fab, or pilot line for it, where we are going to put equipment as used in the foundries, so ASML, applied materials, so manufacturing equipment. And we are going to develop manufacturing process. We are not going to manufacture, but we are going to develop manufacturing process, some prototypes, some low volume, yes, but not, this is not a factory. This is an innovation factory, if you want to call it. And this is very innovative. We are getting a lot of interest from not only from Spanish players, but also European players to play a role here. Let's move to the next step in the value chain, software, IP. This is a good example where Spain is doing well. In Barcelona, for instance, Barcelona Supercomputing Center. Companies like OpenChip involved, and I think we have somebody from OpenChip today here. And also serious investments, 400 million, Intel 100 million from the European Union. So this is also going well. So this is what I put it as yellow, not anymore orange or red. But the factories is the problem. And this is a picture from Yole, from a research institute. And look how many factories. Factories are the green dots. And the numbers is the number of factories in every country. These are also all factories. And everywhere are factories. Only in Spain are no factories. Even Portugal has factories. Come on. Why? Spain is the 5th largest economy in Europe. We have 45 million inhabitants. Why the hell we don't have factories already for years? We had one, long history in Madrid, but it's not anymore there. So we need that. And this is, for me, the message you should remember today. We need factories. And why do we need factories? Because the factories, if you take front-end and back-end, is 2/3 of the value creation of semiconductors. So if we would say, yeah, we are going to just do design, come on, we are going to miss, if it's a trillion business, if it's 700 million, we are not going to play any role there. No, why not? And don't forget, if you have a factory, you are going to bring the equipment makers, you are going to bring the, chemicals, materials suppliers, you are going to create, construction companies and engineering companies to make those buildings. And this is really long-lasting. It's very important. If you don't do the fabs, you are going to have what? Design and research. You are not going to be a player. So that's an interesting. The only funny slide in my talk. From this gentleman, Jerry Sanders, probably Jorge remembers him. This was the founder of AMD at the time they had fabs. 91, he said, only real men have fabs. Yeah? And of course, so don't comment on the real men, but the point I would translate is only countries which want to play a role in semiconductor need a complete ecosystem, including fabs. Yeah? Because only with the fabs you have the 10,000s of people and the hundreds of companies etc. I'm talking to European semiconductor equipment makers about the Barcelona project, and I say, yeah, are you going to open an office in Barcelona? No, no, this is too small. When you have a few more fabs, we will do it. That's the exact discussion we have. This is a good example of how this could happen. This is a factory which will be built in Vigo. I'm also involved in this one. And this one is going to be a small factory for photonic devices, specific photonic and RF, based on 3-5 compounds. So specifically in this market, they have a quite good understanding of what they want to do and why, and there is a good opportunity that this fab will be a success. And this is just an example, why not? Just do it. This is a startup. This is funded now by SED, by Indra, and by other investors. And they are serious about it. And this is well planned, and why not doing it with some Spaniards and Portuguese people who are now working in Germany, returning to Spain, and just making it. One of my last slides. India. India 10 years ago was nothing in semiconductors. And this is an example of how this could happen. These are really big projects, some of them with 10 billion, 11 billion, no? Big factories, driven by the Indian industry. You probably know Tata. Tata is a giant. They do everything. So they say, yeah, we want to have semiconductors in India. We're going to put 10 billion, make a fab, and we are going to attract some Japanese, Chinese, Taiwanese, not Chinese, but Taiwanese players. They will give the technology. They do a joint venture. Tata owns 51%, he owns 49%, and that is running. Why not in Spain doing the same? We also have Telefonica and SEAT, and you can do the same. So this is something we have to really take from a pool perspective. And the last slide with the content, and then I finish, is this. Why is the company TSMC not investing in Qatar, Saudi Arabia, or even Spain? Spain never asked TSMC to put a factory here. Because these are the... Really? Then okay, illustrate. The point is, because also these companies are practical companies, they look for readiness of the ecosystem. That means, do you have 2,000 people ready to go? You saw the example of the Arizona fab. Not even the Americans have the people. And they don't want to repeat Arizona in Spain, so they have limited capability. So we have to build first if we want this kind of big fabs. It will take years to get there. We will have the 15,000 people somewhere before they are seriously considering this. Talent, as I said, geopolitical stability. I think Europe is fine with that. Yeah, for them, advanced nodes is relevant, not for all. And as I said, money alone can't guarantee semiconductor business. And maybe this slide I want to add, in fact, this is important to understand the importance of having a semiconductor hub as a center in a country where you focus and you create a critical mass so that people will attract big investments. This is what Germany did with Dresden, Saxony, back in 1990. It took 30 years to get where they are, but this is the largest in Europe. So you need to be, this is a marathon, you need to be very long position, but it works. In my case, I put here Barcelona, not because, but if I look from the outside, I'm living in Germany, I look in Spain, I think Barcelona has a very good position to become the hub in Spain, at least one of the hubs if we put more than one. Yeah, and just a summary and done. So, I hope you could see the market is big, there are lots of opportunities, it's very relevant, but there are challenges, and challenges mean also opportunities. And I see this is a very unique time where the roadmap is changing, new materials, new approaches, where new players are allowed to go in. And yeah, we need to have some say in this world. And Europe with 8% is not doing what they should do. And so we need to push to the accelerator. There's a new European Chips Act #2 being planned. and I hope it's going to be better design, it's going to be larger, and we need to be faster. So Daniel said, yeah, this is the one statement. Spain needs semiconductor fabs. And if we don't get this done, forget about this offer. We will remain a niche player in 10 to 20 years. We will do our designs and have excellent research centers. We need to do fabs. And yeah, in order to get there, we will need to prepare the ecosystem and step by step get the first, the second, the third fab installed in the coming 5 to 10 years. That's it. All right, that was my presentation.
Un millón de gracias, Tony. Bueno, yo creo que ya la peli de momento ya van encajando las piezas, ¿no? Igual tenemos tiempo para una o dos preguntas. Tony se va a quedar hasta las 5, así que también tenéis oportunidad de hablar con él a lo largo de la presentación de hoy. No sé si queréis preguntarle algo.
Una cosa,
sí.
Como hay solo 3 fabricantes, ¿vale? Lo que tenemos es que ese oligopolio, como eso es un oligopolio, que suban los precios, al haber poca competencia, hay menos competitividad, se invertirá menos, o sea, como...
No es eso. No, primero te refieres a leading edge, o sea, la parte esa de
los más fabricantes, sí.
Sí, la realidad es diferente, es uno, porque TSMC tiene el 90% del mercado y lo que está pasando así, están subiendo los precios, pero como la demanda es tan grande, TSMC nada más este año va a invertir 42.000 millones en nuevas fábricas. O sea, la inversión va a seguir porque eso viene de la demanda, ¿no? La demanda es lo más importante en el mercado. Pero sí, es lo que decía antes, si tienes en según qué tecnologías, oligopolios o monopolios, eso es muy insano. Claro. Bueno, luego nos vemos, podemos hablar más.
Seguro que sí.
Gracias
a todos. A las 4.